Hello dear viewers, welcome to TV Master. In our today's session, we want to look at question 15 and we shall begin with part A. It says, find the square root of the complex number 24 plus 10i. So we shall look at the solution. How best can we get the square root of this number? One, we shall first of all let the square root of the number which is 24 plus 10i to be in form of a complex number x plus iy. So it means we need to obtain the values for x and y, and we shall have obtained the square root of 24 plus 10i. So let us look at how best we can eliminate this by squaring on both sides. So squaring on both sides will give us 24 plus 10i, which is equal to x plus iy, which is squared. So this is 24 plus 10i, which is equal to x squared plus 2x iy, then plus iy, which is squared. So that is when we expand this. So this will give us 24 plus 10i, which is equal to x squared. This is plus 2xyi. Then I squared is negative 1. So this will give us minus y squared. So from here we can easily rearrange this to have the real part alone and the imaginary part alone. So after rearranging, we shall equate the real parts and the imaginary parts on both sides. So for this to be equal to this, so it means the real part must be, the real part this side must be equal to the real part the other side. So equating our real parts on both sides, equating the real parts on both sides, it will give us 24, which is equal to x squared minus y squared. And this will be equation 1. 2, we shall be equating imaginary parts. Equating imaginary parts. So what will it give? This will give us 2xy, which is equal to 10. And meaning that xy will be equal to 5. So from here, we can also go ahead and say here that y is same as 5 divided by x. We shall call this equation number 2. So from this, from equation 1 and 2, we shall be in position to get the values for x and y. So let us substitute equation 2 into equation 1. So when we do that, we shall have 24, which is equal to x squared minus, this is 5 divided by x. This is 5 divided by x. But the whole of this is squared. So this will be 24, which is equal to x squared minus 25 divided by x squared. So looking at this, we multiply through by x squared, or else you can realize x squared is common. So what you can do is to go on and let p to be equal to x squared. So this means that 24 is equal to p minus 25 divided by p. So multiply through by p, and this will give us 24p, which is equal to p squared minus 25. So you can rearrange to form a quadratic equation. So rearranging, we shall have p squared minus 24p. So we are bringing everything this side, then minus 25 is equal to 0. So solve this expression and get the value for p. So this is same as p squared minus 25p, then plus p minus 25, which is equal to 0. Factors of 25, which you can add to give you negative 25, will be negative 25 and 1. So meaning that p into p minus 25 here, then you will have 1 into p minus 25, which is equal to 0. So it implies p plus 1 into p minus 25 will be equal to 0. So from here, we can go on and obtain the value for p. So we can say either p will be equal to negative 1 or p will be equal to 25. So that is basically what we shall have. So p, negative 1, p is 25. But remember, p is x squared. So, but p is equal to x squared. This implies that x squared is equal to negative 1. So x is equal to the square root of -1, and x square root of a number is a plus or a minus. So x is a plus or minus I. Likewise, x squared is equal to 25. So you can say x is same as the square root of 25 is plus or minus 5. So we shall have our x as plus or minus 5, or x as a plus or minus I. So now from this given point, we have got our x as this and our x as that. But recall that x and y must be real numbers. X and y must be real numbers. So for that case, this part here will be ignored. So this one will be ignored. So for that case, we shall be taking our x as plus or minus 5. So let us look at the value for y. Remember that y is 5 over x. Y is 5 over x. So for y equaling to 5 over x, this implies that if x is positive 5, y will be 5 divided by 5, which will give us 1. So this implies the square root of 24 plus 10i. This implies the square root of 24 plus 10i will become x, which is 5, plus 1 times I. And of course, this will be 5 plus I. Next, if x is negative 5, y will become 5 divided by negative 5. And this is negative 1. Since we have got x as negative 5 and y as negative 1, so it implies the square root of 24 plus 10i will also become x, which is negative 5, plus iy, that is minus I. So that will be our answer. So it means the square root of 24 plus 10i is 5 plus I, or negative 5 minus I. And that will be the answer. Let us now talk about part B, where we are given that if this is equal to 2, show that the locus of z is a circle. Now, in order to show that the locus of z is a circle, we shall try to manipulate this given expression. So we understand that modulus of z, when it is a complex number, x plus iy, is actually same as taking the square root of x squared plus y squared. Likewise, we know that if you have modulus of z1 over z2, this is same as having modulus of z1 over modulus of z2. So we shall be requiring the knowledge of these expressions here. Now, let us try to manipulate this using this property. So we shall have this as magnitude of z minus 2i divided by magnitude of z plus 3, which is equal to 2. So I can easily write this as z minus 2i, which is equal to magnitude of z plus 3. So I can have that to distinguish z and this 2. So from here, we can rate our z to be in form of x plus iy. So this will give us magnitude of x plus iy minus 2i, which is equal to 2 into x plus iy plus 3. So from here we can try to rearrange this such that we have the complex part alone and the imaginary part alone. So this is x plus y minus 2 into I, which is equal to 2 into x plus 3, then plus iy. So we are trying to arrange in such a way that we have the real part alone and the imaginary part alone. So from here we shall use this principle here, that when you are taking modulus of z, which is of the form of x plus iy, it is same as taking the square root of x squared plus y squared. So this will be same as taking the square root of x squared plus y minus 2 squared, which is equal to 2 square root of x plus 3 squared plus y squared. So from here, in order to remove the square root sign, we shall thus have to square on both sides. So when we square on both sides, we shall have this one squared and this one squared. So doing that, it will give us this square will go with this square root, so we remain with x squared plus, can easily expand that, or else I can still maintain this. This will be equal to 2 squared is 4 into this is x plus 3, which is squared, plus y, which is also squared. So this is same as having x squared plus y squared minus 2y plus 4, which is equal to 4 into x squared. This is plus 6x, then plus 9, then again plus y squared. So that is basically what we shall have. So from here we can have this as x squared plus y squared minus 2. This is minus 2, so this will be 4. So minus 4y plus 4 is equal to, we can multiply this through, 4x squared plus 24x plus 36 plus 4y squared. So let us try to simplify this. Take everything the other side. We shall have 3x squared. This will be plus 3y squared. Then again 4y the other side. So we have 24x there. Then 4y. So this is plus 4y. Then for the other side, it will be plus 32, which is equal to 0. So from this given point, you realize this can be written in form of x squared plus y squared plus, when you divide the 3 throughout, this is 8x, then plus 4 over 3y, then plus 32 over 3, which is equal to 0. So when you look at this and the general equation of the line, which is x squared plus y squared plus 2gx plus 2fy, then plus c equaling to 0, you realize this is in this form, which is the form of a what? The form of a circle. So this one here describes the locus of z, which locus is or a circle, which locus is an equation of a circle. So you can go on and get the center of the circle. So the center will be, divide this by 2. So your 2g will be representing 8, meaning g is 4. Likewise, 2f will be representing 4 by 3. So your f is 2 by 3. So this is an equation of a circle that has got the center -4 and -2 over 3. So that is what we shall have. And radius, which is the square root of 4 squared plus 2 over 3 squared minus 32 over 3. So this will give us, so this will be in position to give us the square root of 52 divided by 9. So this is same as square root of 52 over 3. So we realize that this is the locus of z is actually an equation of a circle that has got at the center, which is -4, -2 over 3, and radius, which is the square root of 52 divided by 3. So that part will be answered. Let us now look at 15 part C, which says we need to find the argument of z, which z is -2 plus 5i, -2 plus 5i. So in order to find the argument, what we need to do is to first allocate where this can be. So we have -2 on the real So here is the imaginary axis and this is the real axis. So -2 is on the real axis. So if we have -2 here, then 5 is positive, so we can have 5 there, and likewise it means we shall have our angle there. So this can be our angle theta, and for that case it implies theta will be same as tan inverse of 5, which is divided by 2. So theta will be same as theta will be same as 68.2 degrees. So this is the value of theta. So what will be the argument of z? The argument of z is measured from the positive x-axis, and it should be between -180 to positive 180. So we can take this angle since it is less than 180 degrees. So this angle here is same as getting 180 degrees minus 68.2 degrees, and this will be same as 111.8 degrees. So this will be the argument of z, which we can as well write in terms of radians. In terms of radians, we get this 111.8. We divide it by 180 pi. So when you get that divided by 180, then you'll be able to get a value which is approximately 0.6211 pi. So this is in radians and this is in degrees. So you can write any of the two, and that will be the answer for part C.
Yeah.